Welcome back. So we're now looking at a level 2 functional skills maths paper for the legacy variety. This is the next stage up from the level 1. In a previous paper, level 1, we first encountered averages, which was the mean average, which is whereby you add everything together and divide by the total amount. When we come into level 2, we'll probably encounter some different ones. So one of the ones we can first look at is the median. We'll look at two types of median average. The middle number is in the set of data. That is the median. It is in the middle. For an odd total of numbers, for example, 24, 16, 14, and 19, no set of numbers. Well, we want to find what the median average of the middle number is here. So we first arrange in order from the smallest to biggest, which we can see here is 9, 14, 16, 24. Essentially, then just working was to cross a number from the left and right and keep going until you reach the middle number. Well, it's actually quite useful because odd numbers, odd set of number, we're going to end up with a number in the middle, which in this case is 14. That's quite nice and straightforward for us to encounter. We then come to the other type of median, the middle number and set of data, and this is for an even total of numbers. So it makes it a little bit different. So here we have 30, 18, 12, 36, 8 and 29. So as before, what we do is we arrange them in order from smallest to biggest, or smallest to largest, 8, 12, 18, 29, 13, 36 in this case. We then cross a number from the left and right, as we can see here, and keep going until we come to the ones in the middle. In this case, 18 and 29. This means our two middle numbers are 18 and 29. Not quite as simple as the last time, because we just had the one number. Never fear. Simple as this. Find the median of these two numbers. We add them together. 18 plus 29 gives 47. We then 47 divided by 2, 23.5. So 23.5 is the median. When you have an odd set of numbers, count inwards. The two numbers are in the centre. Add them up. Divide by 2. You'll get your median average. So let's move on. Mode. Most common number, i.e. look at it as the most fashionable. Think of the French word for fashion, which is mode à la mode. Mode means fashion, means the most common in this case. So we look at 10, 12, 15, 10, 12, 15, 10 as our number set here. So what we need to look is for the most common, or the most recurring number. Are 3 tens. Therefore, the modal average of the mode is 10. If there is no number that comes up more than once, then there will be no modal average. Simple as that. Mode is quite a nice simple one to work out. And then finally we come to what is called range. This is the area of variation between the highest number and the lowest number in a data or set of figures or set of numbers. So for example, we have 10, 15, 20, 24, 30 and 45 in this particular number set. We need to find the highest number and the lowest number, 10 being the lowest, 45 being the highest. We then subtract the highest from the lowest, in this case 45 minus 10 gives us 35. That makes the range here, or the average range, 35. So again, just take the smallest, take the largest, and then take the largest number away from the smallest number. Question 1 of this paper, the railway. Answer all questions in this section. Write your answers in the space provided. As mentioned with the level 1 maths paper, the idea of functional skills is to relate it to the activities, whether that be in English or whether that be in maths. So there is always some form of context in the background. So I have an example here is petrol train company. She writes a report for a manager. The table shows the number of passengers who used a train station last week. We have Monday through to Sunday and the number of passengers. What they're looking for here is the mean number. So mean being what we visited in level 1 paper originally, we've add everything up, divide by an amount. So in this case, we will add up Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, and divide by 7 days, because there are 7 days listed down here. So as you can see on this paper here, I've written out everything. Remember, you need to write your sum out to show demonstrating working out and how you arrive at your answer. It is not sufficient just to write the answer. If you do so, you will be marked down for it, because how does the examiner know how you got there? So you need to show your workings out. It even may be the case, if you do ultimately have your answer wrong, but you have shown a logical set of progression, how to actually get to the final answer, you may still pick up points. So why throw away points? Show your calculations. So I've added all the days of the week up, which comes to a total here. I've divided that by 7. The average number here is 23,800. The answer is 23,800 passengers. Please remember, detailed passengers, or your answer could be marked wrong, because you've not said what the number relates to. And reversing the calculation is just very simply taking what I've done previously and just reversing it. So 23,800 gets times by 7, which gives us 166,600. And then what we're looking at there is then we take that all the way back, which will bring us back to 0. Moving on from the previous question, we're now going to have a quick look at percentages. Okay, just a snippet, because this will help you with your next question. So we're going to base this at the moment on finding percentage number to a total number. Right? So the example that we have in front of us here is a school has 120 staff. 70 of those are teaching assistants. What percentage of them are teaching assistants? Okay. So first of all, what we need to do is divide the amount of teaching assistants with the total number of staff. Not stuff as actually written on here. That is your chance to actually observe the deliberate error in the text. 70 divided by 120 equals 0.5833. Okay. This is actually going to be a base figure to work with. So all we now need to do to find a percentage is 0.5833 times 100 will give us our percentage of 58.33. That is a percentage of teaching assistants. So again, 70, which is the number of teaching assistants divided by the total number of staff, gives us 0.5833. We then times that by 100. That will ultimately give us our percentage, which is what we want at 58.33. Last slide, we looked at doing some percentages. This is now going to be a bit of an extension on that with this question. So, keeping with the theme of trains and petrol and trains, Petrol also has this information about the arrival times of trains last week. So we have arrival times, on time, up to 10 minutes late, more than 10 minutes, up to 30 minutes late, and more than 30 minutes late. And under that, we have our number of trains corresponding to the date, which is 187 from time, up to 10 minutes late, 54, and so on and so forth. The train company has a target. 98% of trains must arrive no more than 10 minutes late. Was the target met last week? Show what you said. Okay, so we have 287 trains on time, 54 trains up to 10 minutes late. That's what we need to be concentrating on. It's a matter, firstly, of simply adding 287 trains to 54 trains, gives 341 trains. 17 trains more than 10 minutes to 30 minutes late, 5 trains more than 30 minutes late. Add these up to work out how many trains in total. You can see the sum there, 17 plus 5 equals 22, plus 341 gives us 363 trains in total. So, think back to the previous page. We now need to find how we do this. So, we're looking at the smaller number divided by the bigger number. 341 divided by 363 gives us 0.9393. 0.9393 times 100 gives us 93.93%. Therefore, the answer is no, with the 93.93% of trains being on time. So, what you might like to do is some pause, spend a few moments looking at the answer, spend a few moments looking back at the previous slide, having the percentages, and then try and do the question without the answers in front of you. Or have the question written down and actually try to reverse calculate how the answer got there. That will then give you some additional practice on how to answer this type of question. Last question, look at percentages. Next question is going to introduce you to volume. So let's have a little look first at what we mean by volume. In the level 1 paper, for those of you who looked at it in those videos there, we had area, which was squared. Volume is cubed. Whereas with area, it was length times width. With volume, we go one stage further, which is length times width times height. So that's a little clue, little 3 in here, means you have to do 3 things. The easiest way to do this is we do length times width times height, aka something. The answer should always have a 3 after it, which means cubed. That's a nice clue for you. It's cubed, there's 3 figures involved. So on this one, it's quite simply 5 times 4 times 8 gives us 160 centimeters cubed. And that is how we work out volume of a rectangle. So here we have again a typical functional skills style question. It's setting out something that may happen in reality. Mo manages track repairs. He needs to order 60 tons of stones for a track repair. The stones are sold in full cuboid containers. A full container of stones is 80 by 80 by 70 centimeters. Mo knows that 1 meter cubed of stones weighs 1.8 tons. Each container of stones costs £45 and 16 pence. Mo wants to order the smallest number of containers of stones as possible. Work out the total cost of containers of stones Mo needs to order. So we need to start slowly breaking the question down so it helps us to answer it. Our answer will need to be meters cubed. So everything needs to be the same unit of measurement. Makes our life simpler. So remember, 100 centimeters equals 1 meter. So think about that. Here, 80 centimeters becomes 0.8 meters. And 70 centimeters becomes 0.7 meters. We now multiply 0.8 meters by 0.8 meters by 0.7 meters, which gives us 0.448 meters cubed, which is the volume of the container. The 0.448 meters cubed we then times by 1.8 tons. This shows, again through steps, that 0.8064, there are odd numbers here, I know, tons are in each container. We need to look at 60 tons required, so we do 60 tons divided by the 0.8064 tons per container. This will show that we have 74.40 containers required, but when you think about questions like this, we can't have part containers. You have 74.4, your automatic reaction is to start rounding down. Remember, 1 to 4 we round down generally, 5 to 9 we will round up. In this instance, we cannot have part containers because if we do, and we round down, there won't be enough stones for the track repair. That's why we need to go up to 75 containers, so we actually have enough stones to complete the track repairs needed. 75 containers, we then times by the cost of an individual container, which is £45.16. 25 times £45.16, simple multiplication, gives £3,387. Therefore, your answer will be the total cost to order is £3,387. We now find a different style of question for question 3. There is a high-speed rail track between London and Manchester. The length of this track is 210 miles. A train departs at 11:20 and arrives in Manchester at 13:28. The train company claims the average speed of this train is 104 miles per hour. The question is asking now, is the average speed of this train 104 miles per hour? So, different style of doing an average here. So, first of all, we need to look at how long, or what the time difference is between 11:20 and 13:28. In this case, we just take the larger number away from the smaller number, 13:28 away from 11:28, so 11:20, sorry, gives us 2 hours and 8 minutes. Now, remember, as we had in level 1 paper, if you looked at that video, 60 minutes in 1 hour. 60 plus 60 plus 8 is 128 minutes, which is our 2 hours, 8 minutes. 60 minutes per hour. The distance is 210 miles. This is where we're thinking miles per hour, etc. It is better to put everything into minutes because it's going to make our time simpler, or our working out as simple as we can see here. 210 miles is then divided by 128 minutes, which basically gives us 1.640625 miles completed in a minute. We then need to consider, right, so that's per minute, but we're looking for an hour. So this is now where, by putting our hours and minutes into minutes, our question becomes a lot simpler to deal with, because we're just timesing the miles per minute, which is the 1.64 large number, etc., by 60 minutes, which is in 1 hour, which gives us the speed of 98.43 miles per hour. By simply breaking it down, we have now achieved our answer. Our answer is no, as the average speed is 98.43 mph. So what I suggest you do, again, is one of those slides you might want to put on pause, reflect, look through, and take some time to digest how it's actually put together and how the question is actually broken down. And again, what you will need to do is when you do these type of questions, you will need to show your steps to ensure you achieve the maximum amount